Hello guys, this is Akhil. In this video we are going to see classic problems of synchronization using semaphones. Write a program to simulate the concept of reader-writer problem using C++ or Python, and write a program of simulation of producer-consumer problem using semaphones using C++ or Python. Write a program to simulate the concept of dining philosopher using Python or C++. C++, I think. Semaphore synchronization tool that provides a more sophisticated way for the process synchronization their activities. Semaphones is an integer variable can only access it via two individual automatic operations, wait and signal. Original called P and P. And definition of wait operation is wait of s while s is less than or equal to 0. Busy or wait. Definition of signal operation is signal of s and s plus plus. And a bounded buffer problem, producer consumer problem. Let's get into the codes. This is the code for bounded buffer problem, producer consumer problem. We have initialized global mutex of empty full and defining here wait of find. If find equal to empty, global equal empty, empty of equal to -1. If find equal to mutex, global of mutex equal to mutex -1 equal to 0. If find equal to full, global equal to full and full, and we are defining the signal find equal to empty, global of global empty is incremented. If find equal to mutex, global mutex and mutex will be incremented. And if find is equal to full and global equal to global of full and full will be incremented. And let's and n equal to int of input, enter the buffer, so we need to enter the size, and we initialize the buffer and mutex, and empty is equal to n, and mutex is equal to 1 and full equal to 0, and we taking the value of 1. Print of 1 of produce tab space of t2 dot consumer tab of and exit, and choose equal to int of input of enter the choice, which will be the input, and if equal to choice equal to 1, if mutex equal to 1, empty not equal to 0, and print enter the value and wait of empty and wait of mtn, and buffer dot append of input is signal of mutex and signal of full. We should enter the values here now, and else print buffer is full, and if choice is equal to 2, and if full greater than 0 and mutex equal to 1, wait of full and wait of mutex, and print the consumed value is plus string of buffer of pop of length of buffer -1 and signal of mutex and signal of empty. Print of buffer is empty. Elif choice equal to 3 and break is, and elif is print of invalid input. Let's run this. And we're entering the size here as 3, and we should produce 1, and we're entering the values 5, and we're entering the choice as we need to produce, and entering the value 7, and we enter the choice. We are entering the choice is 1 to produce, enter the values. We should enter we are giving the number as 3, and enter the choice. We need to consume, and it shows the consumed, and enter the choice the consume, and it shows 7, the consume value 7, and enter this choice to consume, it shows the values of consume values 5, and we need to done this and exit. And next, this is the code for and this is the code and it's writing problem reader item, and this is the code for the reader problem. First we need to random import the shuffle size and global mutex is empty and which global mutex is index of WRT and defining the weight of find if find equal to empty global of empty minus 1 equal to 1 if find is equal to mutex and global of mutex and mutex will be decremented and if find is equal to full and global full and full will be decremented and if find equal to WRT and WRT will be decremented and we are defining the single signal of find if find equal to empty global of empty will be incremented if find equal to mutex global of mutex will be incremented if of find equal to full global full will be incremented and defining the readers reader count is equal to 0 weight of the mutex and read count is equal to 1 and if read of count equal to 1 and weight of WRT signal of mutex and global count as a index and we need to print the reader plus string of index plus string of count and the interior of incremented if read of count equal to 0 then signal of written and the signal of mutex and define writers weight of WRT global count comma index count into or equal to 0 to print of writer plus a string of index and modify to string of count index will be incremented and signal of WRT mutex is equal to WRT equal to count equal to index is equal to 1 and read count is equal to 0 and definition of a reader of writer for I in the range of 15 choice FNS. Let's run this. Let's see the writer one is modified cut into 2 the reader is CNT S2 and writer 2 modified CNT to 4 reader 2 CNT count as 4 and this. Let's get into the next code. It's this dining the philosopher problem. Dining the philosopher problem. From the random input choice global A, we are defining the weight of the process of num global A and A of process of num minus 1 equal to 1. Defining the signal of process num number global of A of process of number it will be incremented and A equal to 1, 1, 1, 1, comma 1 and we are going to print allow the philosopher to eat at a time. Okay, we are initializing the while I equal to 0 and process of number is equal to 0, 1, 2, 3, 4 and copying copy 1 we are in here is equal to process of numbers and copy 2 is equal to process of numbers and p equal to int 1 of the it at a time and 2 of it at a 2 time and exit and while I less than 5 and random the process choice process num and wait random the process and wait random the process of percent 5 and print string of random of the process is granted to it and print of the p string of a random process of plus 1 of percent of length of copy plus is waiting and print of p plus string random process of length of copy 1 minus 1 length of the copy 1 is waiting signal of random process plus 1 of percent 5 process of num dot remove of random process I equal to 1 if length of the process of num equal to 0 break and we are initializing the elif the process 2 and c is equal to 0 and j is equal to 0 and while j is less than 5 and random the process is equal to choice copy 1 weight of the random process and weight of the random process plus 1% 5 print of the process of the random process and string of the random process of 2% 5 and granted to it and print p plus string of the random process plus 3 modulo length of copy 2 is waiting and print is and p and the string of random process plus 4 and the modulo length of copy 2 plus is waiting signal and random process signal and random process 1% 5 copy dot 1 removed and the random process and I incremented if length of the copy 1 equal to 0 break if p equal to 3 and the loop is break shows first we are giving here one candidate at a time. One we should grant to it, then p1 it's showing p1 is granted, p2 is waiting, p0 is waiting. And here, next p2 is granted to it, p3 is waiting, p1 is waiting, p4 is granted to it, and p0 is waiting, and p3 is waiting. And it shows p0 is granted to it, p1 is waiting, and p4 is waiting, and p3 is granted to it, p4 is waiting, and p2 is waiting. Let's one candidate, this is the output, and two candidate comes here. P4 and P1 are granted to it, P2 is waiting, and P3 is waiting, and P2 and P4 are granted to it, P0 and P1 is waiting, P0 and P2 are granted to it, P3 and P4 is waiting, P3 and P0 are granted to it. Next P1 is P1 and P2 is waiting. Next P1 and P3 are granted to it, then P4 and P0 is waiting. That's it. And let's check this. Let's exit this. Okay, that's it.